Today I am going to discuss about uni-junction transistor UJT. It is a three-terminal device, emitter, base B2 and base B1. It consists of N-type silicon bar and small P layer is placed one side of the N-type bar. N is lightly doped, means number of charge carrier is less, and P is heavily doped, means number of charge carrier is more. From P layer, the terminal is emitter E, and from N-type bar, the terminals are base B2 and base B1. So it is a three-terminal device, emitter, B2 and B1. This is the symbol of UJT. Now I will draw the equivalent circuit of UJT. So here PN junction form one diode, and between base 2 and base B1 form one resistance. It is called inter-base resistance. This terminal is called emitter, base B2, base B1, and this resistance is RB2, this is RB1. So RB1 plus RB2, that is the RBB. It is the inter-base resistance. Inter-base resistance. The range of inter-base resistance is 4.1 kilo ohm to 10.2 kilo ohm. And here RB1 is the variable resistance. Whenever UJT is offset, the resistance RB1 is very large, and whenever voltage applied at point P, so conductivity increases, so resistivity decreases, RB1 will be decreased, and RB1 is vary from 4.1 kilo ohm to 40 ohm. During up period, the resistance is very large, that is 4.1 kilo ohm, and whenever voltage increases, so conductivity increases and resistance decreases. So resistance decreases to 40 ohm. So it will vary from 4.1 kilo ohm to 40 ohm. Now A fixed voltage is applied to base B2 and base B1. Fixed voltage VBB is applied between B2 and B1. So, suppose this is the point A and voltage appears across the RB1. That means potential at point A is equals to VA. If we apply potential divider method, so voltage across RB1, we can write VBB total voltage by total resistance RB1 plus RB2 into RB1 is equals to RB1 by RB1 plus RB2 is equals to RBB, that is the total interbase resistance of UJT, into VBB. And here RB1 by RBB is called intrinsic standoff ratio. It is denoted by eta. That is eta VBB. Eta is the intrinsic standoff ratio. The value of eta is varied from 0.5 to 0.8. Now, a variable voltage is connected between emitter and base B1, is VEE. So when VE is less than VA, here potential at point A, VA is equals to what? That is the eta VBB. So when VE is less than VA, so diode is reverse bias condition. So UJT does not get turned on. Whenever VE is less than VA, UJT is in off state. And whenever voltage VE increases and more than the VA by the amount of diode threshold voltage, so UJT will get turned on. So whenever voltage VE is equals to VD plus VA, so UJT will turn on. So here VA is equals to VD plus VA is equal to eta VBB. So whenever VE reaches this voltage, that is also called peak voltage, UJT will be turned on state. Next, VI characteristics of UJT. It has three states: cutoff region, negative resistance region, and saturation region. Whenever the voltage at point E, VE is less than the VA, when VE is less than VA, so device is in off state condition. Only few amount of current, that is called leakage current, will flow through the device. So this state is called cutoff region. And whenever voltage at point E reaches the peak point voltage, Vp is equals to, that is Vd plus eta Vbb, Va, that is the eta Vbb. So when Ve reaches the peak voltage of UJT, so UJT will be turned on and emitter current increases, which flow through this path. As emitter current increases, so voltage will be decreases, because uh, if current increases, so conductivity increases, so resistance RB1 decreases. So voltage drop across RB1 will be decreases. So here if current increases, but voltage will be decreased up to valley voltage, and corresponding current, the current will increase IP to IV. This state is called negative resistance region, because current increases but voltage decreases. That's why it is called negative resistance region. And after valley point, the emitter current increases, so voltage increases slightly. That is stable. That's why this region is called saturation region. Okay. Thank you.